Hello, my essay is on future of pavement. Sorry, I have a cold. So, future of pavement, according to Llewellyn K. 2019, which is my citation, rapid urban expansion and growing number of behemoth infrastructure projects have spiked the demand for sand. So, Vietnam might run out of sand as early as 2022, and the rest of the world might face the same issue by 2050. Sand, we use it for glass, bricks, roofing, and more importantly, concrete, which is the topic of my essay. This is why the future of concrete cannot stay the same way it is or will run out of sand sooner than later. Another reason I feel like we should change the way our concrete is formed is because the way it's made is not efficient. We are cited from WBC. Concrete production has resulted in 2.8 billion tons of carbon dioxide, which is between 4 and 8% of the world's greenhouse gas emissions. So not only is it like the second most used substance, we're going to use it for the rest of our lives, it's also harmful to the world as well. So with all this information, however, we still need to use concrete because there's nothing else we can use that is as good as concrete, because we still need to build new buildings, houses, schools, etc. So we as a society need to come up with an alternative to still make concrete, but without destroying our world. So the most analyzed form of an alternative way of making concrete is incorporating plastic. By swapping sand for plastic, a team of researchers had found that making a product that has the potential to cut materials, carbon emissions, and recycle plastic, all while making a better type of concrete. So by Cousins 2019, they wouldn't actually be completely swapping sand for plastic. They would be swapping 10% with plastic. So it's still using sand. But they found that even incorporating 10% plastic, it can save over 8 million pounds of sand per year. The unfortunate part is that study with the plastic, it showed that it's not as strong as normal concrete. But this is not bad news, because even though we wouldn't use it to build like skyscrapers or like big buildings, it could still be used in our everyday lives. So this type of concrete with the plastic in it, we could still use it as sidewalks, because it wouldn't carry as many pressure as cars and stuff. So with humans walking on it, it would be able to be used. And it's still a positive impact because it's helping with the waste on plastic and reducing the use of sand. Another study that incorporated recycled plastic was into like an asphalt street, so it wouldn't be mixed in the concrete, but it would be like a part of the layer in the pavement. So they made two parts. The first part is a functioning layer, and the second part would be a load-bearing structure layer. So there's 5 layers total in this pavement design. So the first part would be asphalt, of course. The second part would be a steel plate. Third, thermal installations. Fourth, plastic. And fifth, gravel / subgrade. The reason the design would consist of a plastic layer is, as they quote, it would help with resistance to shock, wear and heat, easy to process at a reasonable cost, and the use of refabricated plastic can improve construction efficiency and effectively reduce environmental pollution. So again, while it doesn't solve the sand issue, it does make it more environmentally friendly choice, and it wouldn't cost as much maintenance because you wouldn't have to maintain it. It would be more durable. It would be more durable and a long-lasting road, so it wouldn't need as much maintenance. So the last 2 studies I found was by MET and MSU. So they not only incorporated plastic into their concrete mix, they did something to the plastic before they incorporated it. So MIT, they exposed plastic flakes to harmless doses of gamma radiation, then pulverized the flakes into fine powder. Then they mixed the plastic with a cement paste, and they found that it was 15% stronger than regular concrete. So the reason they did the gamma rays is because they knew that just adding plastic to concrete would obviously not be strong enough. So they found proof that with the portions of the gamma radiation, it would make it stiffer and help improve the concrete. Not only stability, but also the reduction of emission. This is promising because they obviously haven't tested it that much. They haven't put it into a road. They haven't used it in real life, but they said it's very promising results. Another study that does kind of the same thing with plastic, but not really, is Montana State University, where they used bacteria to coat the plastic, which sounds really weird, with a thin mineral layer, allowed it to bind better to the concrete. So with this discovery, they tested the strength of the new concrete and compared it to normal concrete, and it essentially had the same strength. Now, regular concrete is good as it is, we've been using it for years. So once they realized, hey, we can use plastic and make the same strength of concrete, that's a good sign because we can still use recycled plastic. And not only would they just be able to use water bottles, whatever, they would be able to use this type of plastic called 3 through 7, which isn't accepted into most recycling facilities. So they tested that kind of plastic as well, and it had the same results where it was just as good as regular concrete. So this would have a much more positive effect on the environment so that they can reuse plastic that normally wouldn't be reused. So at the end I said, after all the studies, there's a glimpse of hope and reassurance that we can still use concrete, but in a more durable and environmentally friendly way. Whether it is by using plastic right into the concrete, adding a layer of plastic, or replacing sand with plastic, all these options will be in more discussions in the future when it comes to the making of concrete and pavement design. Thank you.